resistance is 1.5, velocity is 15, density of the belt material was given, which is 1000 kg per meter cube. Very good. So he has given us this particular statement where he says the net tension in the belt is equal to 2 times the tension in the slack side. So that particular sentence was given in the problem. So we followed that particular sentence and framed this particular equation, which says T1 minus T2 is equals to 2 times of T2. Okay. So from there, what we have done? So first we need to find here. First we need to find, just a minute. So power. So what is the power that can be transmitted? That you have to find. And next we have to find what is the maximum amount of power that can be transmitted. And what is the maximum amount of velocity of the belt that can be achieved. So these two things we need to find out. So let us see how to solve this problem. This is very easy. Just we need to compare the equations. Okay. So initially what we have done is, we don't know e to the power of mu theta. So that is why we have done all these exercises. So in the question, it was given clearly that it is T1 minus of T2 is equals to 2 times of T2. So first, for that, we have considered the value of Tc. So that's why. So T1 minus of Tc, T2 minus of Tc, and again T2 minus of Tc, of course. So once we have considered the value of Tc, so this is the final equation what we have obtained after solving. It says T1 minus of Tc divided by T2 minus of Tc is equals to 3, which can be approximately written as sigma 1 minus of sigma c is equals divided by sigma 2 minus of sigma c is equals to 3. We have called these two equations as 1. Now what you have to do is, all of you go for the equation number 14.3 C or D in page number 291. There you can find these two expressions. There you can find these two expressions where it says T1 minus of Tc divided by T2 minus of Tc is equal to e to the power of mu theta, and sigma 1 minus of sigma c divided by sigma 2 minus of sigma c is equals to e to the power of mu theta. So these two expressions can be found there. So now I want you all to compare the equation number 1 which we have framed and equation 14.3 C and D which is in the data handbook. By comparing these two equations, what inference can you get? What inference can you get? Yes. Compare the equation number 1 and compare the equation which we have taken from the data handbook. So from this, what inference can you get?
The end part of the equation, sir.
Yes?
The end part of the equation.
E
E,
power
e, e, e power mu h is, that is
Simple, isn't it? When you compare, the LHS of these two equations are same, so that I can equate my RHS, which is e to the power of mu theta, is equals to 3. That is what I have done here. I have taken e to the power of mu theta as 3. Is that clear?
yes, sir.
Good. Now, once this is obtained, no, you can use this expression to calculate the power. Same old expression 14.5a, page number 291. Just substitute all the parameters which is given. E to the power of mu theta, you can directly substitute as 3 here. So that is the only a twist or turn I can say in this particular problem. That's it. Everything is else the same. Calculate this and give me the value. So 14.17 kilowatts. Everyone getting the same answer? Good, good, very good, very good. So now power value is being calculated. Now what you have to do is we have to calculate what is the maximum amount of power that can be transmitted. Okay. So this is the right now this much amount of power is already being transmitted. Now you have to calculate what is the maximum power that can be transmitted. For that, what you have to do is you have to use a certain condition which is known as maximum power condition, which is known as the maximum power condition. What does it say? The maximum power condition says when your tension in the tight side, which is the value of T1, when the tension in the tight side, that is the value of T1, if it is equal to 3 times the tension in centrifugal action, so that is known as the maximum power condition. When the tension in the tight side is equal to 3 times the centrifugal tension, then your belt would give you the maximum power transmission. So that is what we call as maximum power conditions. According to maximum power condition, what you can say, T1 would be equal to 3 times of Tc. Similarly, if I want the value of T1, so if I want the value of Tc, what should I do? I should do it T1 by 3. Similarly, it goes for the stress also. If I want the value of sigma c, what I have to do? I have to do sigma 1 divided by 3. That is 1.5 is the value of sigma 1, isn't it? Divided by 3. So it is 0.5 megapascal. Next, you have to calculate the value of sigma centrifugal stress, the value of sigma c centrifugal stress. This you can get in the equation number 14.3f, page number 291. Kindly have a look into the data handbook before you take that particular equation. Don't just blindly take it. You have it here. Stress in the belt due to centrifugal force. Okay, so it is given by this particular equation. I have picked that particular equation. Now, you know all the values, just substitute it. And calculate the Vmax. I did not tell you about the Vmax, isn't it? So, when you substitute sigma c here, whatever the value of velocity you get, that is known as Vmax. That is a maximum velocity at which the belt can rotate, at which the belt speed is limited. So apart from this, you cannot go because of the centrifugal tension force. Okay, so you calculate Vmax now from here.
$22.3.
22.36. So this is the maximum velocity to which you can transmit the things. So how will you calculate maximum velocity? Maximum velocity can be calculated using centrifugal stress formula. Okay. Next. Now, there is one particular formula in a data handbook. Now, Vmax, anyhow, you have calculated. The only leftover in this particular problem is you need to calculate what is the maximum power that can be transmitted. Now, in order to calculate that, there will be an expression in data handbook per mm square of the belt. It is irrespective of the belt parameter, irrespective of how much width it is, irrespective of how much thickness it is. So, irrespective of that particular aspect, you will be having a power transmitted equation. That means it will be given as the power transmitted per mm square of belt. Please refer your data handbook and let me know, do you have that particular equation in your data handbook which can give me the value of power transmitted irrespective of the belt dimension per mm square? (14.6a). Okay, exactly 14.6a. So this is for the higher velocity. Higher velocity in the sense, this particular equation can be used if it is greater than 10 meters per second. If it is less than 10 meters per second, you can go with the other equation. Okay, same thing. Where sigma c will not come. That's it. Everything else is same. So pick this particular equation. This is the maximum power that can be transmitted. Okay, pick that. You know the value of sigma c. You know the value of v. It is not just v. It is v max, guys. Okay. So I'll just highlight this. You should not get confused. So it is not just V, it is Vmax there. Substitute all the things and give me the value of Vmax that can be transmitted. So this particular formula, per mm square formula, you have to use when you are in a position to calculate maximum power, Pmax. When Pmax is being asked, you have to use 14.6a. Else, other formula which regularly you are using, no, same formula you can use. Whenever he asks for maximum power, then only have to use this particular formula. (0.004). Okay, fine. So this is per mm square. Don't worry. Don't be frightened with the values. Okay, it is per mm square. That's why the value will be very, very low. 0.0149. Okay. Now, since this is per mm square, multiply it by area. Area will be in mm square, no? So that will get in kilowatts. Okay. So multiply it by area of the belt. So area of the belt is nothing but it is 12.125 cross 10. So 0.0149 cross area. So 0.0149 cross 125 cross 10. So what is the maximum power? (18.62). So 18.62 is the maximum power that can be transmitted. But how much actually you are transferring? You are transferring only 14.17. What is the maximum power that can be transmitted? That is 18.62. Nitesh, you had some doubt?
Yes, sir.
Huh.
Sir, ಅಲ್ಲಿ V ದು
What
ವ್ಯಾಲ್ಯೂ
was that?
15 ಅಲ್ಲ, V ದು ವ್ಯಾಲ್ಯೂ 15 ಅಲ್ಲ, 19.13 ಹೇಗೆ ಸರ್?
ಎಲ್ಲಿದೆ 19.13?
ನಾವು ಪವರ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದ್ವಲ್ಲ, P is equal to BTV. ಇಲ್ಲಿ 19.13 ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದಿರಲ್ಲ.
19.13. 19.13 ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡು.
15 ಮಾಡ್ಲಿಕ್ಕಲ್ಲ ಸರ್?
ಅಲ್ಲ ಕಣ, V ಎಷ್ಟಿದೆ?
V 15 ಅಲ್ಲ?
V15 ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡು. ಏನ್ ಸಮಸ್ಯೆ ಏನಿದೆ? ಹೌದು, ಗಿವನ್ ವ್ಯಾಲ್ಯೂ 15 ಇದೆ ಅಲ್ವಾ? The
ಇಲ್ಲಿ ಸರ್
velocity
ಒಮೆಗಾ
which is
ಇಂಟು ವಿ ಸ್ಕ್ವೇರ್.
ಇಲ್ಲೋ
ಬ್ರಾಕೆಟ್ ಒಳಗಡೆ ಸಹ ಇದೆ ಸರ್ ಒಂದು ವಿ.
ಎಲ್ಲಿದೆ ವಿ ಬ್ರಾಕೆಟ್ ಒಳಗಡೆ? ಹಾ,
ಒಮೆಗಾ
ಇಲ್ಲಿ
ಇಂಟು ವಿ
15
ಸ್ಕ್ವೇರ್.
ಹೌದು ಕಣ, ಇಟ್ಸ್ 15 ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ಲಿಕ್ಕೆ. ಕರೆಕ್ಟ್. ಇಲ್ಲಿ 15 ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ಲಿಕ್ಕೆ ಹೀಗೆ ಎಷ್ಟು ಬರ್ತದೆ ಹಾಗಾದ್ರೆ?
Sir, it comes 14.09 something, sir.
I'll check here itself, man. You also check, I will also check. ಇಲ್ಲ ಎಲ್ಲ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿ ರೆಡಿ ಇಟ್ಟಿರ್ತೇನೆ ನಾನೆಲ್ಲ ವ್ಯಾಲ್ಯೂಸ್. ತೊಂದರೆ ಇಲ್ಲ. 125 ಕ್ರಾಸ್ 10 ಕ್ರಾಸ್ 5 ಸಾರಿ ಕ್ರಾಸ್ 15 ಡಿವೈಡೆಡ್ ಬೈ 1000 into 1.5 minus 1000 into 9.81 into 15 square divided by 10 to the power of 6 into 9.81. ಆಮೇಲೆ ಇನ್ನೆಂತ ಇದೆ? 2/3 ಅಲ್ಲ ನೆಕ್ಸ್ಟ್. ಸೊ ಇಟ್ ಇಸ್ 2 divided by 3. 15.93 ಬರ್ತದೆ. ಕರೆಕ್ಟಾ?
Yes, sir.
15.93. ಈ ಕರೆಕ್ಟ್ ಉಂಟಾ ನಿತೇಶ್ ಎಲ್ಲ?
ಹೌದು ಸರ್.
So the 15.93 is the maximum amount of power that can be transmitted. Is the actual amount of power which is being transmitted, but maximum how much you can go? You can go up to 16.62 kilowatts. Is this problem clear? Any doubts in this particular problem? Any doubts?
No, sir.
Okay, then. So go with the next problem. Please copy this particular problem. We will start. So, do you have any solution? Because these problems would be very, very lengthy. It kills our time. It takes around 10 minutes or 15 minutes to copy, just to copy the question. Do we have any alternative solution for this to avoid this time loss?
Screenshot, sir.
Screenshot is fine, but I want you to write, no? With the screenshot, how can you?
We leave the space, sir.
No, man. You have to look into the problem statement every time, whenever you want certain values. No, in between when you are solving, you have to frequently have an habit of looking into the question.
Before the class, you send the questions, sir.
Before the class itself, okay. Will it not be an extra burden to you to write the questions before the class? Daily after the class. Okay. Okay, man. I will give you 2 problems. Okay, only 2 problems. So that you write and keep it ready. We will solve in the next class. We will have this habit from now. Is that fine? Is that okay with everyone?
Okay, sir.
Okay. So I will be posting the questions in the Google Classroom itself. We'll be having a common platform. Space for that's again a problem. You will never know how much space it takes, isn't it, for one problem? You would never know. It may take around 5 pages for a problem. It may take around. This is very simple problem. Hopefully, it takes only 1 page. This particular problem. So that is a different issue. No issue, man. We will have 5 minutes. Anyhow, it will be like a relaxation for us to write. Okay, but please do write the questions. Please do solve in the class. That is very, very important. I keep stressing that. Just because it is a design subject, if it was another subject, theoretical subject, I would not so much stress upon you. Okay. So So once you have finished copying the question, please let me know. I'll be waiting for you.
Sir, done, sir.
Okay, dear. Yeah. Okay. So this is very easy problem. Already we have solved a couple of problems on this. Same texture, same pattern. Okay. Let us see what all this particular thing has. So a compressor is driven by 900 rpm motor by means of 250 cross 10 mm flat belt. So the given belt here is the flat belt. I just write it flat belt. So whenever I say flat belt, so it would be something like this. The width is being clearly given. How much it is? It is 250 mm, which is the value of P, and the value of thickness is being mentioned as 10 mm. Okay. The motor pulley is 0.3 meter. So motor in the sense it is a driver. Understood. So this particular has 0.3 meters, nothing but 300 mm. Next, and the diameter of the compressor pulley. So compressor, which is driven. How much is that driven? Capital D, which is 1.5 meters. So I can take this as 1,500 mm. Okay. Now, next, what else is given? What else is given? Where was I? The distance between the centers of the pulley is 2 meters. That means C value is how much? 2000 mm, or I can say it as 2 meters. So in the if you are comfortable, you can just draw a small diagram also. 0.3 meters motor pulley, big one, 1.5 meters compressor pulley. So this is how it is being attached. Okay, so this is driver, no? Driver, which is motor, and this is driven, which is compressor. Sorry. So all the parameters are being mentioned here. Next. A jockey pulley is used to make the angle of wrap on the smaller pulley 220 degrees, he says. What do you mean by jockey pulley? Anyone knows about it? Anyone knows about the jockey pulley? Anyone heard of it somewhere?
It is an external pulley, right, sir?
Yes, it is an external pulley. Not this pulley, nor this one. It is an external, another one, third party. So how it is being installed? See, look at the tensions in the belt now. So this is the tight side and this is the slack side. Look at the tension, how it is there. So what is the angle of wrap now? From here to here. So this is the angle of wrap, whatever we are achieving now. So what I do is, in order to increase the tension of the belt, in order to increase the angle of the wrap, what I do is I introduce a jockey pulley. Jockey pulley in the sense it will be something like this. Okay, what I do, I just move this jockey pulley into the belt in the tension in the tight side or in the slack side, preferably in the tight side. So when I move it, what happens? Just a minute. When I move it, what happens is the tension would be increased. The tension would be increased, something like this. Okay, I'm not good at drawing them. I'll try max to convey this to you. Okay, when I do something like this, what happens? The tension will be increased. Hope you got the imagination now, right?
Yes, sir. Yes, sir.
So this
Yes,
is
sir.
the jockey pulley. So why he is doing is, so previously, if you observe the angle of contact, no, it was something from here to here, right? This much, around 180 degrees. Because of the introduction of jockey pulley, what happens? The angle of wrap gets increased a bit. Now, what is the angle of wrap? Now, the angle of wrap is being increased to how much? On the smaller pulley, it is 220 degrees. And on the larger pulley, it is how much? 270 degrees. Can I get the values in radians immediately? Pi by 180 multiplied by pi by 180. So just because of the introduction of the jockey pulley, what happens? The angle of wrap gets increased. Normally it would be 180 plus or minus for all the pulleys. If you introduce a jockey pulley, the angle of wraps get increased. Okay, more power transmission you'll have. Can I get the values in radians, guys? Please be fast. 220 for the smaller one and 270 for the larger one. 3.38. Okay, 220. This is for 220. 3.38 and 4. Okay, 3.38, 4.71. So these are the values in the
So 3.83, sir.
yeah, 8.83.
3.83, sir.
Smaller 3.83.
3.83.
3.83, sir.
3.83. 3.83, 4.71. Clear alla? Iಷ್ಟ ಆಯ್ತು. Next ಏನು ಕೊಟ್ಟಿದ್ದಾನೆ? What else is being given? 0.5. The coefficient of friction between the belt and the smaller pulley is 0.3, and between the belt and the larger pulley is 0.5. So coefficient of friction is being given directly. So I would take that value. So mu s is how much? 0.3, and mu l is how much? 0.5. So these two values are given. I have written there. The maximum allowable belt stress is 2 meganewton per mm square. So what is this? This is nothing but the value of sigma d, which is being given. It is 2 meganewton per mm square. Specific weight of the belt material is C. He has directly given the value as omega. It is not density, which is given. Observe the units. It is in Newton per meter cube. So it observe the units very carefully. So it is 9.515. Since it is Newton per meter cube, I have directly taken it to be a weight density or specific weight of the material. Kilonewton per meter cube. Determine. So after all, what you have to determine is what you have to determine to find the power that can be transmitted. So what is the power transmitted is the question after giving each and every data in this particular problem. I told you in the first class of the design, if the question length is increased, you are the luckier ones. So don't feel bad if the question size is a little bit big. If it is a little bit big, you'll be having more data in the question. We need not calculate much of the data. But if dangerous questions are those whose question line or length of the question is very, very small. Okay. So you need to calculate power. So if you want to calculate power, first you have to decide whether to consider the value of centrifugal tension or not. So in order to take that decision, what you must calculate first? What you must calculate first? Velocity. So yes, go with the calculation of velocity now. Go with the calculation of velocity. It is pi into small d is 0.3. Small d is 0.3 plus thickness 10 mm in the sense in the meters it is 0.01. ns speed ಕೊಟ್ಟಿದ್ದಾರಾ speed driven by 900. So ns is 900 rpm is given. 900 rpm. So I will take that value. Velocity ಎಷ್ಟು ಬಂತು? Which is the value of velocity? .6 is the velocity. Yes. So what decision have you made? What decision have you made after seeing this value? Since 14.6 is greater than 10 meters per second. So should we consider centrifugal tension or should we not? Should we consider centrifugal tension? ಮಾಡಬೇಕಲ್ಲ 14.6 ಬಂದಿದೆ velocity. So write a statement there. Since V is greater than 10 meters per second, since V greater than 10 meters per second, considering centrifugal tension. I told you in any problems in the belts, two important conditions, two important decisions you have to make. One is that whether you have to consider centrifugal tension or not. That is one condition. Second condition is where you decide whether to work on the motor pulley or on the compressor pulley, as in this case, which pulley to be considered to work upon to calculate the power. Whether should I consider the driver or a smaller pulley, or should I consider a driven or a larger pulley? Which one to consider? So how do you consider? How do you make this decision? Already you have made one decision. You are going to consider the value of TC since the V is greater than 10. Second decision you have to make whether to consider the smaller one or we should consider the larger one. So how do I come to a conclusion and how do I make a decision on this? Which one to consider? How do I come to a conclusion on this? Such type of problems are done, right?
So driven.
So how did you come to that conclusion?
Because the jockey was introduced and the tension is high, sir. So
Okay, you should not blindly come out that particular thing. I told you have to calculate the value of mu cross theta or e to the power of mu cross theta. Any one of the value you have to compare. So which one is smaller, that you have to take. You have to calculate e to the power of mu theta for this, and you have to calculate e to the power of mu theta for this. So which one is smaller? If the larger one is smaller, then you have to take this. Okay. If the other one is smaller, you have to take this. So just write it here. Since mu is different for both pulleys, design is based on the pulley having the smaller value of mu theta. So just substitute the things up there. For the motor pulley, the value of mu was given as 0.25 cross 4.71. And for the fan allied, it is a compressor, I guess, right? Compressor, it is 0.5 cross. This is another problem, man. Okay. Okay. First one is motor. Motor is a smaller one, so it is mu s cross theta s. Mu s is 0.3 cross theta s is 3.83. Next is compressor. So there you have mu l cross theta l. Mu l is 0.5 cross theta l is 4.71. Yes, what is the value? .143. So 1.143. You cannot say it as a weaker. But the thing is, you can decide that you will consider this particular value. That's it. 1.141.
sir, 1.149, sir.
149, huh? Okay. So 149 and 2.355. So which one is smaller? Motor pulley or small compressor pulley? Mu theta value. So motor pulley has been smaller. So pick this particular value based on the motor pulley. Motor pulley mu theta value is 1.149. Okay. So now go with this particular formula. 14.58291. Substitute everything. I would just check the substitution. V is 250, T is 10. What about V? 14.61. Yes, 14.61. Sigma D is 2. This I have substituted is 9.15. Very good. 14.9.81. Very good. E to the power of it is not 1512. Rather, what we have got is 1.149. From this, what is the value of power output? Power transmitted in kilowatts directly. Okay, 44.7 kilowatts. So that's the end of the problem. Okay. Okay. So you just take a screenshot of this particular problem. We'll solve it in next class. Okay. So mark your attendance in the Google Sheet. Submit today's classwork, whatever you have written, 2 problems. Submit that, scan it. It hardly takes 30 seconds for you. Scan it, upload it, finish your class. Mark your attendance in the Google Sheet, finish the class. That's it. Okay. So classwork 7/06/2021 is being specified there. Every class will be having the submissions. Okay. So once you have done those 2, it hardly takes around 1 minute for submission and few seconds for marking your attendance. Mark that and leave the class. We'll meet up tomorrow. Okay. Take care.
Sir, can you just scroll it, sir?
Sir, Sumit present.
ಸರ್ ಅದು ಲಾಸ್ಟ್ ಕ್ಲಾಸಿಗೆ ಸರ್ ಅಟೆಂಡೆನ್ಸ್
131.
ಹಾಕ್ತೇನೆ ಒಂದೇ ನಿಮಿಷ. ಓಕೆ, ಈಗ ಹಾಕಿ ಎಲ್ರು. ರಾಜ್ವಿಕ್ ಹೇಳಿದ್ದ
ಸರ್ 042
042 ಕ್ರಿಟಿಕ್ ಇಸ್ ಹ್ಯಾವ್ ಮಾರ್ಕ್. ಸುಮಿತ್ ಹೇಳಿದ್ದ
Try mark.
Okay, pa. And parallelly submit your classwork in the Google Classroom.
Sir, can you just scroll up, sir?
Sir,
Yeah.
ಅದು ಚೆಕ್ ಮಾಡ್ತೆ ಅಂತ ಹೇಳಿದ್ರಲ್ಲ ಐದು.
ಹಾ, ಚೆಕ್ ಮಾಡಿ. ಮಿಥುನ್ ಅಲ್ಲ? ಓಕೆ, ನಿನ್ನ ಒಂದು ಕ್ವೆಶನ್ ಎಂದು ಹಾಕಬೇಕು. ಓಕೆ ಪಾ, ಚೇಂಜ್ ಮಾಡಿದ್ದೇನೆ ಮಿಥುನ್. ಹಾ, ನಿನ್ನೊಂದು ಕ್ವೆಶನ್ ಮಿಸ್ ಆಗಿದೆ ಮಾರ್ಕ್ ಮಾಡೋದು. ಚೇಂಜ್ ಮಾಡ್ತಾರೆ.
ಸರ್ DME2 0 ಹೊರಟಿತ್ತು.
ಶಶಾಂಕ.
ಹೌದು, ಅಪ್ಡೇಟ್ ಆಗಿದೆ.
Thank you, sir.
ಓಕೆ, ಶಶಾಂಕ್ ಅಲ್ಲ? ಇಲ್ಲ, ನಿಂದು 48 ಇದೆ ಸ್ಕೋರು ಶಶಾಂಕ್.
112
ಶಶಾಂಕ್ ಕೆ ಅಲ್ಲ?
ಅಲ್ಲ 112 ಕೆಳಗೆ.
ಹಾ, ಶಶಾಂಕ್ ಎಸ್ ಕೆ ಹೇಳ್ತಾ ಇರೋದು. 48 ಇದೆ.
ಓಕೆ ಸರ್.
ಓಕೆನಾ?